Okay, thank you very much for showing up today. We want to turn that up? All right. If you have any questions, please make sure that you gotta be ready. I'm just telling you, you gotta be ready. You gotta be ready. You gotta make sure the person's looking at you to throw it through. All right, that's my only I don't know what you do. Do you have an extra pen by chance? By chance? I don't have one. Oh, I just built it yesterday. Hide behind me. All right. Let me see if I can find a pen thing on my desk. I want it back because it's from Princess Cruises, right? High quality H2O, right? Okay. Okay, so I gave you guys, and by the way, on the internet, what we have in front of us and what you should go ahead and bring up on your computer is basically your Unit 1, Lesson 13/14. It's the same sheet for both of them. Laboratory on temperature of water and soil. All right? Now, what we'll do is we'll set up the lab. We'll hang over a quick explanation. We're going to write down some numbers as they come up, and during the time we have to wait, I'll explain, hopefully, what you're seeing through dance. We're going to be here a while. Yeah. What's funny is I did take an interpretive dance class in college. You? I don't know. Yeah. They're like, make yourself happy about it. And they're like, do like interpretive dance. Like, it's actually kind of cool because you got to see your nonverbal. I recommend taking one. Or just walking on campus doing that. All right, so if you go online, hopefully give me a smiley face if you have that up. Thank you very much for having that up already. I'm going to go and share my desktop real quick, and I'm going to bring up the virtual lab. So let me see here how I can do that, because I forgot. Show view application. Sure. I want to share. Fire. I want to share that. Okay. I don't know if I can see. Okay, do me a favor. Give me a smiley face if you can see the screen. It looks like it's some sort of a lab. Cool. Perfect. I can leave it like this. Okay. So on this screen right here, we have a few things. We actually have a reset. I need to reset this clock. 0. Put this on the. Come here. Stop it. Stop it. I need to reset the lab first. Okay. So, okay. I see soil and I see water. All right, so what we're going to see here is, what do you guys notice we have on this page here also? Yeah. What? You see the timer? That's good. That's probably for time, I'm guessing. What else do we need? Thermometers? What's that for? Check temperature or something? Average kinetic energy of molecules? Cool. What else do we need? Yeah. Light. I see light. So, okay. Do you have maybe a heat lamp of some sort? What else do we need? That's my hand. Don't make fun of it. You need to get that checked. Yeah, I just will be patched right now. What else do you see? Yes, an hour. Is that What's the timer again? I see a timer straight. I see a timer straight. All right, what is this, do you think? Depends on water, box of water, all right? Cube of water. What does this do you think? Dirt, soil, whatever. Okay, what you're seeing is the exact same surface area volume of water and soil. You're seeing the exact same heat length. You're seeing the same temperature. You're seeing everything. You're seeing all the same stuff. What we're going to do is what we're going to set up. And what you guys are going to set up is I'm going to put the thermometers in the water, in the soil. I'm going to turn the heat lamps on. I'm going to hit the timer, and we're going to see what happens to the temperature. That's what we're going to do right now. Okay, in between the times, because it's kind of boring to sit there and stare at me. I know a lot of people look at me. I know, because I'm the teacher. But I'll go over some other things that help you hopefully understand what you're actually seeing. So, do me a favor though. Question number one, same with the peeps at home. It's asking you a question. What it's going to say is, I'm going to put thermometers in both these water and soil. I'm going to turn the heat lamp on. What do you think is going to happen? Well, I don't know. Right now, sure hypothesis online. Just FYI, there's no wrong hypothesis if you really think it's going to happen. It's what you think is going to happen. You can write down whatever you want, not whatever you want. Something that's related to it. I like hamburgers. That doesn't work. I don't like hamburgers. I like tacos. I don't like tacos. I like it. Pizza's better. It's really excuse today. Good? I would agree with you that pizza is better. I do agree. 3-1. All right, so I'm going to go ahead and start putting the stuff in here. Okay, so what are you noticing of the temperature right now? On both of them. And are they equal to each other? Guess what? They're the same temperature. That's how they do. All right, so what I'm going to do is I'm going to hit start. So go ahead and write that down. It says at 0 minutes. So that's now. That's like before we hit the button. You'd write down, both of them are 19.8 degrees Celsius. Yeah. All right, I'm going to go ahead and turn the lights on to both of them. And then we will hit the timer, and then we'll have to pay attention. Now, do me a favor. You all need, I'm going to use all on stuff, all right? I'm teaching this stuff, hopefully. I need you to pay attention to the, some of you guys just look at the timer every once in a while, and at 1 minute, like 10 seconds before, give me a heads up. Like, it's reading the timer, and then I'll stop so we can look at it and all write it down, okay? Then at 3 minutes, right? And then at 5 minutes, at 10 minutes, and then hopefully I'm winding down by then, hopefully. I've had a lot of caffeine. I don't know if that's going to happen. You ready? Okay. On. Is it on? Yeah. On. Sorry. Okay. Really? You do know the rule, right? We got that. Crap. Yeah. I totally forgot this during the Buddy McDonald. All right. All right, so, okay. So this is a couple things. I've been throwing around these planets around the room. By the way, if you're at home, I have these 2 balls that are shaped like the Earth, and you can throw them around the room. You can, just... All right, so this is a ball, obviously. It's the shape of the planet, obviously. Now, question for you. What do you notice when I spin this? What color do you see? All right, we need to write this down. Stay calm, stay calm, stay calm. 22.5 and 20.6. 20.5 was. And then the other one was 22.6, I believe. All right, so there you go. That's the first one that her number. Use that down to that one. And then this one goes to 90. Okay? All right, so again, what do you see? What color do you see mostly? Blue. Okay. What do you say blue? Should be blue. Why do you see mostly blue when they spin the thing? It is mostly water. You're 100% correct. You said all proper. What's the percentage? Do you know? You sure somebody did? It's not 75.99999999999. Repeating, of course. I don't know. It's like 70. It's in the 70s, all right? It's a C average, all right? Yeah. 70. All right, so it's about 70% water. Okay, real quick. You know how much of the water on the planet is drinkable?
Like 2%. So,
Okay. 3% I believe is fresh water of the 70. 3% is fresh, and 2% is lost and stuff that we typically don't drink, like a glacier. Like no one really walks up to a glacier perhaps and like licks it. Wow, I'm really refreshed today. Okay, no one does that. Right? No, that's 26. 1% is the ones we typically drink. Only 1% of the water on Earth we actually drink. That's how you can believe it. All right. All right, so same time. Does anyone know an interesting thing about water? Read that time?
yeah.
I was making sure. I was freaking out myself. Okay, we come to this 3-minute mark. We need to write this down because this is imperative to life.
You have a board of conversation.
Maybe. We need to write this down or it won't happen. So we have 27.6 and 22.1. All right. So this is the thing. This is mostly water. And you have land here too. Why is the temperature so different around the world? I mean, it's mostly water. Why is it?
Because of climate, consisting of the rotation of the sun, the
Rotation of the sun? The sun rotates. It's so slowly.
The sun of the rate of the sun, the position of the continent, which causes different climates around the world.
We'll go with that first. All right. Question: where's been to the beach? Here, raise your hand if you've never been to the beach. I recommend going. Here's a hint. If you go west from here and you just keep walking, if you don't stop walking, you'll probably drown in the ocean. Just saying. That's how you can get there if you don't know how to get there. Or you can go east, a longer way. Same exact way.
Going up this now.
Not those guys. All right, so the beach. Everyone's been there, right? Okay, I make a joke, but last class I really did have students before that did not ever go to the ocean. They'd never seen the ocean. They lived in Anaheim, California. There's reasons I won't go on to right now, but they didn't leave their city because they were in the game and couldn't. So, but they never saw it. I couldn't explain it, but you guys all know it. So you get to the beach, all right? So you get to the beach, all right? So let's go. We're going to the beach. You get to the beach.
Yes, I am here.
Yes. Oh my goodness gracious! Woo! We almost let it fly. We got to pay attention here. 33.6 and 23.6.
Yeah, that's 22.
Whatever I said. 23.6 is still a water limit. All right, so you drive to the beach, right? And not you, because y'all see you drive most of it. So you go, you get down, most of you. You get there, you park, right? You get out of the car, and they're like, "Thank you for sleeping. I appreciate your back, sorry." You know, run to the water, right? And so you're walking, get out, you have your flip-flops. You're like this, and you're walking in the sand, right? It's how to walk, right? So you're walking, you're walking flip-flops in the sand. It's weird, right? It flips the sand up right here, and you're like, it's like weird. So you take your sandals off. You step on the sand. I don't want to hear your answer. Don't do it, because you have a really better answer than I have. All right? So you start walking in the sand. And it's hot, right? You just stand there?
No.
What do you do? Run, okay. The smartest person in the room in the corner said, "Watch this barrier feet in the sand." I'm like, okay, you're right. I could have just went under the sand and it would have been perfectly cool. You're right. Yeah. All right. But what you do is you run to the water. So this is you, like, get out of the car, and then you like, "Oh, it's hot." And then you run like this, right? This is how you run. And people on the internet can't get to you running with Mr. Hayden, but it is amazing. It's like sprinting, like an Olympic sprinter. It's very much the same motion, with more arms flailing. All right, so you said it's hot, right? Feet hot. So where do you run? Where do you run? Circles, you go. In circles, it's still hot. I don't know what to do. You run to the water. Okay, you get to the water. You run into the water, and you go. And smoke comes off, or steam comes off the feet, right? Why? Question is the water cooler or warmer than you just had? The water colder or warmer? Is that really like a cold? You don't know the water's cold? It was weird, right? You know what's weird is because everyone in this room knows their science. You know. Sun comes up, into the sky, stars in there. You all know this stuff. You just don't know like the technical words that go along with it. Well, you don't know. So if you go, you don't know why certain things. But you know it's hot in the sand, and you know it's cold in the water. But you know why. It's specifically not you. Anyone else will know. It's not you either. What do you think?
The sand is supposed to come.
So there's water.
Larger body of water than the sun.
Okay, and what does that matter?
Larger than quantity to quantity.
Okay? Well, remember that when we see this. Because when we start seeing this, remember the exact same quantity. And we're seeing one more much faster than the other. So would that be agreeing or disagreeing with your analysis? Disagree. But it's fine. It's a good concept though, because you're really close on it. Okay, so you get to the water, it's cold. And the reason why it's cold is because water is different than sand. Water acts different than sand. Water has what's called a high specific heat. The molecules of water to agitate, to become hot, take a lot of energy. A lot of energy. The sand, not so much. So as the sun comes up, it starts to warm up. It's a low specific heat, high specific heat. That's the only real difference. And so water, example, if you're boiling water, you have a big pot of water, okay? You sit on your thing, you turn it, you light it up, it's all hot. How long does it take to boil the water? Forever. I did it last night. And I was like so like impatient. Like I'm like so Google, like I'm just Googling the answer. And I put it in the, you know, put it on the stove and I'm like, okay, cool. I do this, I do that, tell my son, doing this, you know, whatever. Come back like 10 minutes later, I'm like looking at the pot, I'm like, anytime you're ready to boil. I'm on the little super boil thing on the whatever, it should be working. And I go back and like, it sat on me for like 20 minutes with a full flame hitting the bottom. Like I would burn my finger if I got anywhere near it. But it's taking us about 20 minutes to boil. Ridiculous. The government really has got to do something about that. Okay, so what happens is it takes a lot of energy. I'm talking a flame sitting on it for a long time just to boil this much water. So you're going to have a difference in temperature. So you have your area of the sand, let's just say, this is water, this is sand. Guys got this? Okay. People on the internet, imagine a blue folder on the desk. I don't know. Same person. So here's the blue on the desk. Here is the sand. So as sand, the temperature rises. And what happens to air? What happens to air when it gets warm? That's boiling. 44.8 and 27.4. Okay, now I'm going to go ahead and turn off the light. And in 5 minutes, so at 10 minutes or 15 minutes and 10 seconds, we're going to relook at the temperature. Okay, so you have the temperature of the thing, all this air warming up. What happens to air when it gets warm? It gets hot. Yes, the air when it gets warm, it gets hot. Move past that. Okay, what happens to the air itself? When you have a two-story house? What happens? It gets hot upstairs. Why? Air does well when it gets warm. It rises just like a hot air balloon. So this air rises off the sand. Literally, it just like goes up, like it just goes away. So what happens? People on the beach just die because there's no air anymore. Like, no, they stay alive pretty sure. What happens?
The cool air comes in from the bottom, and then the process starts over again.
Yeah, some dancing, okay? Interpret dance. So basically, the air rises, warm air comes in. What is it called when you have air moving fast? It's wind. Air moving fast is wind. Would you like some artificial wind? I can just blow on it. Wind. All right? Just fast moving air, okay? That's all it is. And so we get this, that's why we use the beach, sometimes you get that cold air hitting you, like kind of warm, and it's like, oh, that really feels like a nice sea breeze. That's what you're feeling. You're out there, you're feeling the air coming from off the ocean, cooling down to get near the surface, and coming towards you, and you're getting all like excited because it's cold. Yes, how can I help you this time afternoon? Make sure.
Is that the other real question? Is that why the water's so cold?
Yes. And honestly, water being cold is your perception. That's all it is. Something is all perception. Example, if I got into, like, if I went into say I jumped into, I bucked the challenge. It was all cool like 6 months, a year ago. Okay, I jumped into, say, instead of a bucket, I jumped into an actual like pool of ice cold water. I'm talking 33, 34 degrees, almost freezing. Okay, and I jump out, and I run inside the water will feel warm.
Yeah.
But if I sit in the sun for 20 minutes, get in a tan, because, I mean,
You need water.
I need a tan. I mean, we're not going to lie here, right? So when I run and I get all warm, and I run into the ocean, is it warm or cold? It's your perception. It's your perception. That's all it is. It's what is it now and what are you going to? What is the difference in temperature? The biggest difference, it's 110 degrees and it's 30 degrees outside. That is a huge change in temperature. It'll probably hurt your body. I know someone in the past that jumped literally within in a rainforest. And whatever it was like 95 degree temperature humidity, jumped into like a water pool, like, you know, waterfall, which the water is actually freezing, believe it or not, because it comes off a higher elevation, and was paralyzed on the right side of the body. It happened to happen to that person. No one, real person that actually happened to. And because their body cannot do this, the adjustment of change so quick. So, but it's just the perception, how you feel. That's why at night, it's super cold outside, and you jump in your pool, and it's warm. But then the next day, it's super hot outside, and you jump in your pool, and it's cold. Your temperature stays the same temperature. It was the same. Your perception changed. That's the only difference. Okay? It's all perception. All right, so that's what happens with the air. It goes up and it flies underneath. So that's one of the reasons why it matters if there's a lot of water somewhere or if there's a lot of land. For example, let's use this area. Who here lives within Lake Elsinore, Menifee, Paris, whatever? This side of Ortega is in this vicinity. Most people in this room, okay? During the summer, what's the average temperature? I like to say the sun. It's like 90, 100. It is hot. Why? It's basically kind of a desert. It's hot. But at night, what is it super cold or super warm? Does it stay hot? Stay night. Okay. Well, in the desert, believe it or not, it actually gets cold. There's huge fluctuations in temperature because of the lack of water, basically. But if you go over there to the Orange County, Orange County, you only see a difference of like 10 to like, okay, this many degrees at night and this many days. It's about the same because the water keeps pretty consistent. So one of the questions that you guys will see on the back, we're getting ready to hit our first 5-minute mark. You'll see a question that'll say like, what is the difference between Maryland and like Kansas? Kansas is in the middle of the United States. Maryland is next to the Atlantic Ocean. That probably affects what is asking you. 15 to 10. More early. All right. We're going to write that down. Oh, sorry. It was 41.3 and 25.5, I think it was. I don't know. That's what I said. It doesn't matter. I'm showing you the concept, not the actual. Right. All right. So that's what you see there. So in general, guys, a couple things you remember. Earth covered mostly with water. The land is there. The land heats up faster and cools down faster than water. Water takes a long time to heat up and a long time to cool down. In an area that there's a lot of water next to it, it stays pretty consistent temperature. I asked the question, have you ever been to the Caribbean or the Caribbean? Raise your hand if you've been to the Caribbean and or Caribbean.
I'm to the Caribbean.
It doesn't count. You get to meet with them. That's why it's here. That happened in like December. See something? There you go. So when you went there, I was with you. I was hoping you guys did sign up for I was hoping. You guys went there, right? So where did you go? Bahamas. This is the largest thing on that over. There is, huh? Okay, Belize. All right, very good. All right, so, and I just so you know, I went to St. Thomas, St. Lucia, Barbados, and a few of the cruise we kind of just traveled around. Really, I recommend it. Okay, let's go. Okay, what do you guys notice about the temperature? Humidity. Temperature, not humidity. Temperature is humidity. What was the temperature like? During the day? What was it like at night? Day, night, day. Winter, summer, day. Okay. Okay, that's the way it is. Okay, very consistent when there's a large body of water. Now, have anyone ever been to Mammoth? Okay, been to Mammoth during the summer? Been to Mammoth during the winter? You've never been to Mammoth during the winter?
No, my dad's company has a condo out there, so.
No, you've never been there in the winter, you ain't talking about. You've been there in the winter and during the summer. Different, right? Hot, snow.
Well, I mean, either way, it's pretty cold.
Still cold, but big difference in the company. What I'm saying is that areas of land change a lot. Areas of water doesn't change very much. It's just the way it is. So remember that when you're answering that last question. Do me a favor, I'm going to pass around, I'm going to have the sign-in sheet for you. You can go ahead and sign that, sign on that, the dotted line. I'm actually going to go ahead and stop this recording. And we'll discuss it a little bit, but you can definitely answer the rest of the questions online if you get a chance, okay? Okay, question. Jacob, if you have 2 sessions, which you're not even in there anymore, awesome. You have 2 hours to come to mine and 2 hours to go to Matt. Figure it out, please. Okay, the essential question for this session is basically going to be, what is the difference, or why is there a big difference in temperature, say, here in Lake Elsinore in comparison to the other side of the Ortegas and Mission Viejo and Lake Forest? Like, why is there a big difference between the temperature here and the temperature there? So use the concepts you learned today and go to answer that question. And please put that inside the Dropbox inside the class for credit. Thank you. Have a good day.